Hello. So earlier this year, I did a teardown of this Mi Air Pump 2, and Xiaomi has released the Xiaomi Air Pump 2 Pro, and by popular request, we're going to be taking a look at that today. Here we have a carrying pouch. So for reference, this is the pouch for the 2, that one, and this is the new one. This one's got a little pocket for the accessories. This one also appears to have a little pocket. Here we have a pouch of accessories. It's fairly long. It's about a foot long. This time we get a USB cord. Looking at the accessories included with the 2 Pro and the 2, it looks like they're almost exactly the same, except for the hoses, where the 2 Pro is about twice the length. The pre-attached hose to the new pump is slightly longer than the old one, but otherwise they are about the same. So here we have the 2 units side by side. As you can see, the 2 Pro is significantly larger than the 2. The 2 weighs about 476 grams, and the 2 Pro weighs 879. Looking at the bottom of the 2 units, we can see that the visual design is very, very similar. Both have a charging port and some ventilation. Moving on to the back of the units, we can see that the 2 Pro adds a very large flashlight that the 2 does not have, and it also increases the thickness. There is a bump for the flashlight, and there's a nice raised foot so that the pump does not wobble when sitting on a flat surface. Moving on to the top panel, we can see that both retain the flashlight on top, except the unit is of course larger, and there's the addition of a button to release the air hose. However, I believe the ends of the air hoses are the same between the 2. The air hose that comes with the 2 is slightly shorter, and this one's slightly longer, and of course we have the extra long one included as well. On the front panel, we have an extra protective ring around the display on the 2 Pro, where on the 2 it is a flush design, and we have the same button layout, and the physical design on the sides is very similar overall between the units. The flashlight on the new one is quite easy to use. Simply press and hold this button and the top light will come on. And to cycle between modes, you can simply press this button, quickly press this button, and it will cycle between modes. So here's the top flashlight, here's the back flashlight, here's the SOS mode, here's the red colored SOS mode. There's no full on red mode, unfortunately. And we're back to the top flashlight mode. To switch it off in any mode, simply press and hold that button again, and it should turn off. Overall operation is very, very similar to the 2. There's a battery indicator. You're able to switch between set profiles and modes, and you'll be able to change the pressure. I believe pressing and holding this key changes it from PSI to bar. And of course, if you were to set 55 and then go to bar, it converts the units for you. So you could use this to convert pressure units if you wanted to. Let's have a look at the notable differences we can see between the 2 and the 2 Pro so far. Both have very, very similar layout internally. We have a very similar display as well. The batteries, there are actually 3 battery cells in the new one. you cannot see them right now. There are two on the in the 2. The air pressure sensor appears to have been moved internally, and overall there's not a whole lot to see. We can see the difference in the cylinder heads. The cylinder head of the new one appears to be much larger, with a heatsink on it, just like the 2. The airflow is roughly the same, with 2 fans, with a fan pulling air from the bottom and across the motor and through the device. The old one actually has slightly better design, as the fan has a ring around it, and that will keep the airflow moving through the unit. And here, since there's no real ducting for the fan, only just a vent near the fan, it seems like it's possible for air to sort of escape through this crack and bypass through the fan. One of the notable differences between these two is on the 2, the pressurized air goes directly to the outlet, and the hose is only for the sensor, whereas on the 2 Pro, it seems like all of the pressurized air goes through the hose, and the sensor is sort of embedded near the outlet. There are a number of reasons why this could be done. The added space in here could be a good buffer to smooth out the fluctuations in pressure from the sensor, or it could be to reduce noise or provide a little bit of a flexible tube to let things move around a little bit, perhaps, but I'm not entirely sure. Since this is a 3 series battery pack, we can see the battery. I think there's a battery minus, I believe this is the battery negative, this is the positive, and we have 2 extra tabs so that the main controller can do cell protection and balancing, since that's all built into this board now. Having a peek under the insulation plates, we can see that there are customized nickel strips used to connect all the batteries. If you were to replace these cells, you'd probably clip this strip off about here and spot weld the new strips to these end plates so that you get these tabs right. You could probably also cut your own, but this looks like kind of a pain because this has to fit perfectly into the motherboard. So you might want to reuse some of the strips that they give you here. Just to give you an idea of what they look like, we'll do a couple head-on shots so that you can take screenshots or do whatever you want. So after popping all 4 screws off, we can actually see the inside of the gearbox. So inside the gearbox, we have a pinion on the motor, as well as a single stage planetary gear set. We have these planet carriers. We have this ring gear going on. Plenty of grease in here. This is an all metal gearbox. Let's see if we can get a close-up on that. There's a ball bearing in there, I believe. It feels like a ball bearing, and this is the crankshaft. Having a look at the motor itself, we can see that it is rated for 17,000 RPM this time, instead of I think over 20,000 the other motors were rated for. This motor is a lot more beefy than the other ones. It's got a nice cooling fan inside to keep the motor itself cool, as well as these are either interference suppression chokes or something in here. And the motor has, unfortunately, sleeve bearings, but those will probably be fine. Overall, this is a pretty good quality gearbox. Definitely a lot less crude than the bare open gearbox we saw in the other one. Let's have a closer look at all of these components. This is the cylinder, the piston. It has a small bearing attached to it. Looks like it's basically permanently molded into the plastic. So unfortunately, if this bearing goes bad, you're gonna have to replace this whole thing. Again, I don't, some people have asked in past videos where you can get these parts, and I'm not certain where you can get these parts. I know somebody was able to find one somewhere, but I don't know where you would get this, and this bearing is unfortunately permanently attached. The metal part here, it looks like the cooling has been enhanced. There's now cooling fins on the cylinder body. There's little cooling pins on top as well, sort of like a cast piece with lots of cooling surface area to try to get the heat out. For a oil-free pump, and by oil-free they mean there's no active oil lubrication system. For an oil-free pump, keeping the cylinder cool so that this plastic doesn't wear out prematurely is really important. So it's nice to see that they've paid a lot of attention to keeping this cool. Overall, the cylinder bore is about 27.1 millimeters, and the stroke is about 14.64. I measured from top dead center to bottom dead center there. Those are not going to be 100% accurate. They're just for sort of ballpark informational purposes. But this is a pretty hefty piece of metal. A continuation of the design we saw here with this one frame for mounting the motor, the gears, and all that stuff. This is very, very similar. Of course, on the top of the cylinder head, we have the output valve, which is the discharge valve. It's a small piece of rubberized plastic with a spring on it, and of course the top pushes on it, and it seats against this metal ring here. The intake valve is on here. It's the little spring valve heat staked to the cylinder with the little thin legs to allow it to flex. The intake is from the middle of the cylinder. One of the questions people really like to ask is about the pressure sensor. I don't have any way to validate the accuracy or calibration of these, other than these are digital pressure sensors. And the digital pressure sensors are typically MEMS devices that are calibrated at the factory. Here we can see the part number. You can go look that up. The values in the data sheet are probably going to be your best bet if you need more information on the accuracy. Based on my experiences, I have 2 or 3 of these, and these Xiaomi pumps, they seem to all agree with each other. Let's have a look at the PCB next. Here are the 2 LEDs for the top flashlight. That's a connector for the pressure sensor. This is for the back LEDs and the micro switch. And this is the battery charge circuitry. We can see the integrated Njonik IP2326 chip here. It looks like a fully integrated switching boost battery converter. And it has to be a boost because the USB is 5 volt input and the battery is 12 volts. So this is going to be a boost converter with a 2.2 microhenry inductor and a V-bus MOSFET. It's like a diode for reverse polarity protection, I believe. I think these pads are for the 5 volt input. Not sure, but you can read all the information on the passives out if you'd like. And here's the NTC thermistor for the battery protection. The battery pack sits right up against here, and it's actually glued right to that thermistor. So if the battery overheats, that's going to be the detection for that. So this is the top side of the board where most of the interesting stuff is happening. Here's the main controller for the whole device in general. That's going to be running the screen, running the program, controlling all the buttons. Not much to talk about there. There's the power conversion, DC-DC buck converter. Goes from 12 volts on the battery to about 3.3 volts to run all the lights and all that stuff. That actually might be for the LED light strip light panel on the back as well. Not entirely certain. Yeah, here's some more power conversion stuff. This is probably stuff for controlling the DC motor. We got a couple MOSFETs, I believe, just to handle the current. We have a bunch of gate drivers, I assume, gate drive stuff to drive those. I'm assuming these are for the motor since they're close to that, because the motor is connected right back here. Moving on to the middle, we have the battery cell protection, the BMS, and the all the associated parts. I believe this chip is going to be able to talk to the main chip. It's impossible to tell. I believe the older ones did have some form of communication going on, so I don't see why this one would be different. If we zoom in here, you can see the part numbers. It's a cell-wise CW1246, and we can see here, got all the cell filters, because the battery is a 3S battery, so we have the two cell taps that are being monitored by that chip, and that chip's going to do undervoltage, overcharge, overcurrent, stuff like that, and one of these sense resistors is going to be for the controller to detect if the motor is stalled, and the other one is going to be for battery protection, so if you short it out. So if something shorts out on this board or after this board, worst comes to worst, you get the battery chip will cut off the power. Of course, there's actually a fuse here for the actual battery, so if something goes terribly wrong, that should blow. Here we have the NTC for the battery pack. We can see that they've cut out 2 slots in the PCB so that the temperature it's measuring is actually through this glue to the battery cells as opposed to measuring the temperature of this PCB. You got lots of these vias to transfer power down here. Up here we have a screen, and that's your labels for the pinout of the pressure sensor. And of course those are for the main harness that goes to the LEDs in the back. So interestingly enough, it says designed by Hoto. So Hoto is one of the sub-brands of Xiaomi, I believe. Hoto actually do make a small air compressor like this. It was like the Hoto air compressor. Had a very similar looking motor and fan and whatnot in the marketing materials a couple years ago. It's kind of interesting to see. There's quite a lot of, I think they're a separate team, but this whole device looks pretty Xiaomi. This is Hoto Mi Pump Pro VG. It's kind of an interesting Easter egg. So yeah, this looks like the same display, except we actually have an extra feature here. This is the progress indicator, I believe. So I think all that's doing is it's measuring the current pressure in relation to where you've set it to, and I believe that bar is just going to light up as it progresses. Yeah, that was part of the marketing materials for this. But yeah, that's the PCB. Here's a full view of the PCB and the back, in case anyone needs that. So a couple testing notes today. We have an ambient temperature of about 10 degrees Celsius. It's been running for about 10 seconds before the test, which is why we're starting at 43. The temperature sensor is placed right on top of placed at the top of the cylinder head, the metal cylinder head. The voltage and current are being monitored with the oscilloscope through the 2 milliohm sense resistor already on the board, with a couple of capacitors to try to filter out some of the noise. The audio is being monitored for a short period of time through an iPhone app called RTA from Studio 6 Digital. The developer claims to have calibrated the frequency response and decibel level for most iPhone models, and we're using the Z weighting, the flat curve. All of this noise you're seeing here is from the controller doing PWM to control the motor. The problem with doing that is that the motor, being an inductive load, puts these huge voltage spikes out, and the simple capacitor filter I built doesn't adequately filter them out. So what I did instead was, since the current doesn't seem to be changing very much, I took a look at what the signal was like and determined that the controller was operating at about an 88% duty cycle. So I just added that as a correction factor to the measurements after the controller slowed the motor down. So let's go through the test results. From my earlier video, I calculated the approximate volume of the tire I used for the testing. I used the same one for both videos, so you should be able to compare the results across videos, but not necessarily with other things, because this is a very approximated volume. I estimate there's probably at least 10% of error in the volume here. Either way, using the same numbers that we used last time, we have about 0.85 CFM on the Pro versus the 2, which has only 0.41. So the airflow is roughly doubled, which means anything you're trying to inflate with the 2 Pro is going to take about half the time. Moving on to pressure, we can see that the time taken to reach about 35 psi is about half as we expect. The speed is reduced near the end, so the curve is a little less linear than the 2. That is because the pump seems to be reducing the speed slightly, about 75% of the way through. I believe that might have something to do with limiting the amount of power it's consuming from the battery, but we'll touch on that later. It is twice as fast though. Moving on to time and energy, we can see that we have an interesting trend here. While the 2 Pro does take half of the time that the 2 does, it's actually using twice the energy. And by this, I don't mean power. It's not just using twice the amount of power, it's also using twice the energy. Now, while the 2 Pro consumed 10.61 watt hours, the 2 actually consumed almost half the power to do the same thing, half the energy to do the same thing at only 5.336 watt hours. The manufacturer claims that this new one will do 2.5 tires. I think that was for a 205 something. And with a 27 watt hour battery, we're getting, based on our numbers, around 2.5. So I think the tire I'm using is slightly larger, so that is actually pretty favorable, all things considered. We can see that performance does come at the cost of efficiency. Even though it takes half the time, it does use twice the amount of energy. And normally I would say that because of the relatively static losses in running the mechanical system, normally you would expect that the pump that runs for a shorter amount of time is more efficient. But in this case, I think the electrical and mechanical losses from having a much higher power motor basically nullifies all of those gains. Moving on to pressure, time, and power, we can see that the 2 Pro starts out at about 100 watts and it climbs to about 120 watts before the controller reduces the speed of the motor slightly. I'm guessing that is to keep the power drawn from the battery under 100 watts or so, which is probably what the battery is rated for discharging. The 2, since it's only pulling about 40 watts at maximum, doesn't have that feature and doesn't need to do that. The peak power is 120 versus 40 watts. It's almost 3 times the power, but unfortunately, since the efficiency is half, we don't exactly get 3 times the effectiveness. Looking at the temperature, even though the 2 is larger, the power is so much higher that the improved heat dissipation, the larger fan, the improved heatsink doesn't really help. By 6 minutes in, we're at almost 100 degrees Celsius. So the longevity-wise, this is probably going to be doing worse than the 2. There's no way, as I can tell, to decrease the speed and run it slower. So I'm assuming that for long-term use, the lifespan is actually going to be lower since the internal components are running at a much higher temperature. The temperature was measured on the top of the cylinder head, and I believe that is the same location, almost the same location as I measured on the 2. Keeping in mind that on the 2, I believe I probed the head on the outlet valve, but since that's plastic on this one, I decided to probe the actual cylinder head this time. I assume the temperatures should be fairly similar, but they're not directly comparable. We can see that the cool-off period is about what you would expect. The fan's not running, so just slowly cooling off. You can probably extrapolate that, so if you wanted to know how long you should wait after using it for it to cool down, maybe this data is useful to you. Now, one thing I did notice is that on the 2 Pro, there was some air coming out of the missing buttons for the instrumentation wiring. I do not believe that this would significantly affect the results, since the airflow coming out of there would have just gone out the side panel anyway, but keep that in mind. So here we have a summary of pretty much all of the testing we've done. Basically, I think both models have their benefits and drawbacks. The 2 is much smaller and much more efficient. Since they charge at the same speed, actually, because of the higher efficiency of the 2, if, for example, you wanted to use this continuously, you would actually be able to use, it would actually do more compressing per hour, since the power usage is much lower compared to the same charging speed. Now, with the 2 Pro, you do get more accessories. You get like a back flashlight. The larger battery isn't really as helpful because it consumes also about twice as much power. So mostly you get a longer hose. You get some accessories. Now, all of these accessories do work on the 2 as well, so if you wanted just to buy them, that would work as well. But the main benefit of the 2 Pro is it's just twice as fast. And if you're in a hurry, that might make the difference. But I think for, this should say 2 Pro. Buy the 2 Pro if you need the speed or features. Otherwise, the original 2 is probably good enough for most people, I'd say. And it's definitely more efficient. So I'll also just put up the manufacturer's product comparison as well, in case anyone wants to see any of the information in there. But yeah, that's about it for today's testing. Hope you found some of it useful. As always, the Excel data will be in the description. And if you have any questions or comments, I'd be happy to try to answer them. Thanks for watching.